Welcome everybody, my name is James Serra. This is an overview of Microsoft appliances. I know some of you were maybe expecting another session. Due to weather, the speaker couldn't make it, so they called me a couple of hours ago and said, can you do this one? So here I am. Hopefully, on short notice, some of you will understand or read the guide. I don't know what they actually uploaded for the guide of it all, but I'm going to talk about the following. I'll silence your cell phones. They said if I hear them, I can actually take them, and so you don't want to, especially iPhone or iPads, make those noises. So about me, I've been doing this quite a long time. I'm a BI consultant, have been in IT for a long time. I specialize in business intelligence and data warehouse solutions. Tomorrow I'll be giving a talk on the data warehouse architecture. All this probably don't care about, other than jamesserra.com is where I blog about a lot of the topics I talk about here. I go more into detail. Also, you can email me with any questions afterwards. And all this experience hopefully will allow me to interject real-world experience as I'm up here talking about a lot of these appliances. So we're going to cover why use a data warehouse. A lot of times when I give this talk, I'm surprised how many people don't really have a data warehouse. So I want to ask that. How many people here work for a company that has a nice big data warehouse? 1, 2, 3, a little bit. So most don't. So we'll talk about the reasons for using a data warehouse. And then we'll get into your task with building a data warehouse. The first thing you need to do is get the hardware. So we'll talk about ways that you can solve that problem. There's a reference architecture called Fast Track Data Warehouse. And then there's also actual appliances, physical boxes you can buy, and there's a number of them. Business Data Warehouse Appliance, Business Decision Appliance, Database Consolidation Appliance, and the Parallel Data Warehouse. So we're going to cover all those. And my goal is for you to understand all these options out here. Because when I first got involved with databases a number of years, well, a long time ago, but 6 or 7 years ago, when I really started getting involved in databases, I wasn't aware of a lot of these appliances out there. And some of them are pretty new, but 5 or 6 years ago, some of these came out, and they're really a shortcut to a data warehouse solution. So the first thing I like to talk about is why use a data warehouse. Because I go to clients and, oh yeah, we got a data warehouse, okay, what is it? Well, we copy some data from source system over to this database and we run some SSRS reports of it, so we got a data warehouse. Well, that's really a stretch. That's not what I would call a data warehouse, because there are many reasons for a large enterprise-wide data warehouse, such as reduce stress on a production system. I was a DBA for many years, and the first thing on a new job usually is you get people calling you, why is the production system so slow? I'm trying to do data entry. Well, what's happening is somebody's running a report, they wrote a query, they didn't do a good job of it, and it's flooding the whole system and taking and bogging it down. And it's your job to go in there and find out who's doing it and kill their query and tell them don't ever do that again, and then recreate the query for them. So by moving all that data off of the data entry system, because you could be an ERP or CRM system, and people are mostly entering data, and you don't want to compete with that. That's too important for them to be having issues where they get timeouts and stuff. Another reason is to move it off is it can optimize for read access. If you're on an OLTP system, it's for write access, not so much read access. And you can't really start adding indexes and all these things for reporting, because then you're colliding with the people who are doing data entry. So you can tune it when you move it over to a data warehouse for read access. You can integrate many sources of data. Many clients I go to, they're using some say Oracle ERP system, or JD Edwards, and there's a million of them out there. And it's only one source of data. Now they want to integrate other source data. Maybe they want to have budgeting and planning in there. Well, some people what they do is they try to shove that all into the ERP system. A better solution is we'll create a data warehouse and we'll move all the other sources systems into it, and not try to just jam it into our source system. So you can integrate many types of sources of data, and I'm sure you'll see many of your business users will have all sorts of Excel spreadsheets and things that they're using to generate reports. Well, all that can now land in a data warehouse and not on somebody's hard drive sitting somewhere. and keep historical records. There's a couple of ideas with this. One is, is what they call solely changing dimensions or historical records, where if I run a report and I'm looking at all the customers in the state of Texas, and I run this report at the end of the month, and then somebody moves from Texas to California a week later, and I run that report a couple weeks later, well, that user will now show in a different state from when their order actually happened. If you keep historical records, things like solely changing dimensions, what you'll do is create multiple records for that one customer. So from this date to this date, they were in Texas, and from this date, they were in California. So you never have that problem of having data that's changed. And you want to piss off salespeople, have their sales commission suddenly change because of people moving around. The way I see a lot of companies do it, even just happened to me just last week. Oh, well, we just save out all these hard copy reports to SharePoint, and at the end of the month, we just copy them all out there. And you have pages and rows of all this hard copy reports. If you build a data warehouse and it keeps track of the history, that all goes away. It's also a great way to restructure and rename tables and fields. If you're trying to run reports off of like JD Edwards, if anybody here uses JD Edwards, your tables are T1106, T107. The fields are all crazy numbers and not make any sense, and you ask a user to go and build a report off that, or even IT, you're just kind of lost. When you create a data warehouse, you rename these fields and these tables to give them meaningful names, so somebody can look at that and go, oh, I understand it, and they can generate reports off that. And there's companies that all they do is make a living is going to places and writing. They wrote the ETL that moves it from point A to point B, and they rename all the fields when they do that. And they find a lot of companies want that when they build a data warehouse. So there's companies like Noetics and Rapid Decisions, and they just kind of a cookie cutter. They go in, they create this ETL, and you're left with a data warehouse that has meaningful names to it. It also, with a data warehouse, allows you to do master data management. That's a whole other topic in itself, but many times, if you don't do master data management, which is creating master tables, removing duplicates, cleaning up data, those things all go through a master data management product, like master data services is one. If you don't do that, what usually happens is you build a data warehouse, you start generating reports, and the user goes, why is company A in here twice on two different lines? They're really the same company. And you go, oh, we integrated multiple sources, and somebody misspelled them, and we didn't realize that. So what happens is they go and they hard code it. If company A and company B and then the user goes, well, there's like 20 more, and they go, okay, let me hard code them, and they're going back and forth and doing that. And then they say, well, let's create reference tables, and it becomes a big mess. Well, that's what master data management solves. And part of building a data warehouse, and I always stress this, is you've got to think of master data management as part of the solution in there. Think of that up front, so you're not running into that. Because once you run into that problem and the users question the data, you've lost all trust. The users have lost all trust in the data, and then it makes your job a lot more harder. No, so let me clarify that. It's a good question. As the data is going from the source system into the data warehouse, one of the steps in between will be using like an MDS product or DQS product, both of those to clean it up and then send it off into the data warehouse. No IT involvement. I don't know about you, but when I worked in IT, I didn't really enjoy my time writing reports. Business users, okay, can you write this report? All right, I go and do it. No, can you change this? Can you do another filter? Can you order by this? And if you're spending all this time trying to understand the business because you don't really understand the data that much, and now you got to go create those reports. That wasn't a lot of fun. I'd rather give them a data warehouse, making them understand all the data by renaming it, and go. Here's all the tools you can use, because they got a million of them. Go and write your own reports and leave me out of it. Data warehouse allows that to happen. Otherwise, like I'm at the one, they have the Oracle e-business suite, and to get a report done takes literally weeks. They'll have to submit a ticket, and they'll have to get somebody to put it in their queue, and they eventually get it, and they start writing it, and they give it to the user, it's not what they want, and they go back and forth. And the users finally say, you know what, forget you IT, I'm gonna go write one of my own. And they come with some hodgepodge way of creating the report, but they get it because they need it. Improved data quality is another big one, where you clean the data as you bring it over. And I've never been to a client, I've been to many clients where they said, our data is fine, there's no problems with it, and you start looking into it, and you're like, well, what about this? What about this? Oh, well, we had a bug in the system that one week, and data didn't get in there. And so you start finding all these issues. And that either leads to plugging the hole in the source system. I mean, at the client I'm at now, they were putting in years of 2, and some were putting 5,000 in there, because they had to put a date in there, so they just put all these crazy dates in there. Causes all sorts of problems. Well, we plugged that by saying the date's got to be something, reasonable. So you can clean up the data, hopefully in the source system, and hopefully you can plug those holes in there. But it's always going to involve some things you cannot change, and as the data is brought over, you got to clean it up on your own. And the biggest probably thing is the one version of the truth. So many times our clients now, I go and get a report from this source, and somebody else gets from this source, and they're actually trying to report on the same things, but they're getting different results. Why? Because they're using different systems. It hasn't been cleaned and verified, and nobody can trust the data. A data warehouse that says this is our single source of truth, and executives will get to the point where they're going, if it's not from the data warehouse, I'm not going to trust it. Everything's got to be from there, and this is what allows it to happen. And finally, it's easy to create BI solutions on top of that. If you're building cubes, or you're using any kind of other reporting tools, or you're pulling the data into data marts, having it a built data warehouse makes that job so much easier. Because this is what happens. If you're in, say, shipping and you want to get data and you have all these data sources, I may have to pull data from finance and marketing and sales. Oh my goodness, this is a pain in the neck. I got to know what's in those systems, where they are, how to join them all up, how to match them all up. They could be different formats. It's a big mess. If you create a single version of truth, all those source systems are put into one data warehouse, and the joins are all done for you, and the data is clean and normalized, and it's all made similar, then it makes it so much easier to create reports. How many people here are still in the left side with their data needs, right? And how many have this nice clean one? We at least got a couple. That's good. So the point of that is if somebody comes to you and you don't have a data warehouse, or you need to build a new one, and you're the DBA, or you're a manager and you're in charge of building up the data warehouse, the first thing you got to think of, okay, I know why we need one. It makes sense. We got buy-in. Where am I going to put, what kind of hardware I'm going to get? And I've been in the situations many times. You call up, not HP, we're sponsored by Dell, right? We'll call up Dell, and we'll say, I need a server. And you'll talk to the guy who doesn't really know much about what your needs are, and you'll just, well, let's be extra careful and buy the biggest thing. And you get with the network guys, and they hook it up to your SAN, and you're like, let's hopefully we guessed right. Or I've been in plenty of companies where they spend weeks and weeks with the network guys and the database guy and the hardware guys, and they print out all these different hardware options, and they go through this whole rigmarole, and they're evaluating what they need, and after months sometimes they finally come to the conclusion of what they need, but they're still guessing. I mean, I was a DBA. I didn't know a lot about hardware. I assumed that, hey, this sounds good, but I can't test it, especially against the workload that I'm doing. So you're just like, okay, let's hope for this. So what happens in many cases is you have a powerful CPU that can do something like 16 gigs a second, but you can't deliver more than 2 or 3 gigs a second. So that CPU, you'll see, you have a large database and people are complaining about the speed, and you as a DBA or manager go and you look and you'll see the CPU is really low. Well, I thought we got big enough hardware. Well, yeah, but you didn't think about you got a big enough processor, but you didn't think about the disk that you're doing. Or you didn't think about some of the other parts that go into feeding the CPU, because the CPU is sitting there starving for information, you can't get it to it quick enough. And in almost always cases, it's something to do with the hardware as far as the disk space or disk bandwidth like that. And as a DBA, you'll spend more time trying to tune the queries, but there's only so much you can do, especially when it's not a CPU problem. So here's all the different areas where you can have problems. If you look at any system, you can have, and I don't even know what some of these are. I don't know what an SP port rate is. All I know is it's something important, and it's got to be tuned, or it's got to be set a certain way, or else you can have performance issues. So how do I solve this? How do I come up with a solution? And and can be confident that I am going to provide the users with a data warehouse that is not going to have performance problems. A couple of ways to go. There's a thing called the fast track data warehouse architecture. It's a reference configuration. How many people know what fast track data warehouse is or heard of it? A couple? All right. How many know about appliances that you can go and purchase? About half of you. Okay, that's good. So the fast track data warehouse is a paper that you can go and download, and it's going to tell you all the key performance indicators, all the things you should be tuning in a data warehouse solution. This was actually built due to, paper was developed, and this is during the fourth generation of that, over when Microsoft and Dell or HP were building the parallel data warehouse. They would test and they would find ways to tune the hardware to make it quicker, and they said, this could apply to any type of hardware. So they created this reference configuration. So you can call a Dell and say, I want a fast track data warehouse. And they'll give you the recommendations on what parts to buy for that. And there's a lot of companies have that, HP and IBM and all of them. You can even ask them, hey, can you just build it? Okay, these all parts sound good, just build it for me. Or they can give you two and you plug it all together and you install the OS and SQL Server setup. Taking it one step further, an option is to get an appliance where it's built on the fast track data warehouse, but it's even more tuned, but it's also, everything's installed for you. So you literally call them up, I want an appliance, they send it to you, you plop it on the desk or rack and you plug it in, enter a few network things, network domain and password, and you're ready to go. And we're going to cover some of those appliances. So you can take the track here of we have a lot of things that we need to configure and deploy and tune. The hardware, the software, the services. You can see here there's 3,000 software parameters, 500 hardware parts to choose from. On the left side, you can use the guidance where you can build it yourself. As I mentioned earlier, that could take months for you and you could not wind up with a good solution. You can go for the reference architecture. I like when somebody says a cookie recipe. This is what you should do to build a fast data warehouse solution for you. Or you can go the appliance, which it all becomes down to your time and money. If you need something quick, well, you want to go with the appliance. It may cost you a little bit early up front, but in the long term, you're probably going to save a lot more money. Sure. Yeah, and I think that's coming up in one of my slides, but it scales. It could be part of a larger solution. So that is, you have the confidence in knowing what I purchase now can be scaled up in case we need to take it to the next level. Good point. So this is kind of where it fits in, where these three different solutions fit in. You have your SQL Server 2012 solution. So if you have a data, and this is a very rough estimate, a database that's maybe 2 terabytes or lower, you may be fine building on your own and not have to worry too much about the hardware because maybe it's not too big of a database. I mean, but I've seen 500 gigabit terabytes that are extremely slow. It's all about the queries you write and your SLA for what performance you need. If you start getting up higher in the bigger database size, then you've got to be more concerned with the hardware. And so when you start talking about 40 terabytes or so under the best conditions, that's where the fast track data warehouse comes in. And that's where the appliances come in that are based on that fast track data warehouse. Now we're getting to the real meat of it, of big data. What big data is the parallel data warehouse. That's something that scales up to 6 petabyte now. It's a massive parallel processing machine where it distributes the query out. So you'll see some of the I'll go over some samples of what things I've done before, but it allows you to query billions of rows in seconds. Because eventually you may get to the point where I don't care how many SQL servers you have, they're not going fast enough. And yeah, it's big data, and it was funny when we were at one of the earlier presentations, and there was a big full room, and he asked how many people are doing big data, and there was 3 people in the whole room. So a lot of it is still to be done in the future, and the parallel data warehouse, they haven't sold a lot of them, but they're hoping in the future that a lot of this big data push will drive people to a bigger solution. Now, Microsoft is competing with the Teradata and Netezas out there. This is what their challenge to them is the parallel data warehouse, which we'll get into more. So, yeah. So version 2, and I got my list here of all the features because I was verifying it. I went downstairs. It kind of blurs the line a little bit more, where they have a quarter rack now, and you can use the parallel data warehouse for smaller databases, and it's more cost effective. It still costs a hell of a lot of money, honestly, but.
If you burn through 3 years of queries running hours to come back from users, you can open that real quick.
Yeah. So I'll give you an example. One of the places I was at is NASDAQ, or Direct Edge, another. NASDAQ's like the 2nd biggest in the world, and Direct Edge is the 4th biggest trading company in the world. So they had all this trading data that they needed to capture, mainly for to detect fraud and for compliance, and to also help them with understanding what people are doing and how they're purchasing and selling stock to offer them, some of these trading firms, better packages. Like if you make so many trades in an hour or a day, we'll cut the price down. And surprisingly, a lot of the data, when I looked at it, this is getting a little off topic, but there was all these cancellations. And I'm like, why are all these cancellations? 80% of the orders were canceled because people, what they do is they send a bunch of data across to delay the whole system like a millisecond. And that could change the buy and trade delay so they can make a tenth of a penny on it. And I was like, well, tenth of a penny? He's like, well, yeah, but they're putting in $1 million orders, all of them. And it's a way to try to scam the system in a way. So, and as part of the parallel data warehouse, they want to analyze and find out who's doing that and go after them because it's illegal to do that. But I think you'll see, if the cost keeps going down on the parallel data warehouse, that people will see it as an option with smaller databases.
And one of the points you made earlier too, I think it's important for people to look at pricing PDW, is how long you spend speccing a system out, how many different people can get
Yeah.
done, what's the cost of all of their time by the time you get done.
Yep.
PDW, you get it done.
Yeah, right. Especially if you are pretty confident that your data is going to grow. So you sound like a Microsoft guy. That's what they say when I go down there. Just buy it now. Just be safe.
No, I've been involved in a situation where it took 6 months to make a decision, and by the end of that 6 months, it was already to the point where we knew we were going to be pretty much at the end of the capacity of the SAM.
Yeah.
And I kept arguing, look, it doesn't make sense to spend all this time coming up with a reference architecture. There's already one out there that we've been using and generating profit from.
Yeah. Have them come to my session. I'll teach them all that. And the reality is you can't convince certain people. They have in their mindset things like that. But all you can do is try to educate them, and hopefully they'll see the light, right? So the Fast Track Data Warehouse is a reference architecture. Here's some idea of some of the things that it talks about in this architecture, reference architecture to tune. Software, database configuration, hardware system design. Hundreds of, you look at the reports, I think 60 pages now, that gives you this guidance for it. And then the result is, by having this, kind of what you're saying is, you'll have pre-balanced architectures, you'll have multiple choice of hardware platforms, because a lot of companies have this fast track. Your total cost of ownership will be lower, because you're saving a lot of money by not spending all this time, like you were saying, putting it all together. It's going to be high scalable. I knew I had that in somewhere in there. And then you reduce your risk, and that's the big one. I can go and feel pretty confident that I'm not going to have a problem down the road where the system can't handle it. And then, oh boy, now you got to get another hardware. You got to move everything over. What a nightmare that is. I've been through a couple of those. So kind of what I talked about, I think the only one I wanted to clarify was this is a data warehouse workload-centric thing. It's not a one-size-fits-all. You wouldn't want to buy one of these for an OLTP system. This is for data warehouse only. So don't buy one of these and then try to use it for a different purpose. And there's where it eliminates the guesswork and saving you months of configuration, setup, testing, and tuning, especially the tuning part. So some of the best practices that you'll see when you look through this document is related to SQL Server. Even if you're not even going to purchase hardware, some of these methods are actually good, like they talk about the way to load data in there. They have some pretty good ideas of you have a lot of data loaded in there, so it could be helpful for you to read that even if you're not using it for new hardware. So just quickly over this, there's ways of approaching the fast data warehouse. You can use the basic evaluation. You can call Dell and say, you know, this is generally the size of my database. This is kind of an example query we're running on it. What kind of fast track data warehouse do you recommend? Because they have a reference architecture, but they may have a number of parts that may solve that. Do I need a 50 gigabyte drive or 500 gigabyte drive or certain CPUs? By kind of giving them some idea of what your workload is, they can come to a good solution for you. You can take a step forward and actually create a workload that you test on your current system, and you come up with all these configuration or these well, I think I talked them right there. These metrics, and give that number to Dell, and they could use that to even further reduce the risk. Make sure you get the proper hardware because you've tested the common workload for that one. Or if you're real ambitious and you have a lot of time, you can take your own hardware and configure it all on your own and run the workload through it many times until you come up with the ultimate solution. So essentially you're building the hardware, you run a query, you test it, to time it, and then you say, we can get better performance, let's swap this out and out. So you're doing a lot of that work based on what's in the fast track, but you're still doing some of your own tuning. I haven't seen anybody actually do this yet because it's quite intensive to do that. So, but it is an option for you. And these are the metrics. I won't go over them, but you'll see if you go on some of the sites, they'll talk about, hey, if your MCR is between this and this, we recommend this solution. So that's what those fit in there. So we talked about the fast track architecture. Now we're going to get into the appliances some of those are based on that fast track architecture. So, I should have changed this to get rid of HP. Is anybody from Dell in here? All right, good. Anybody from HP in here? So there's a lot of appliances. We'll go over all these briefly. So you have, some of them are still based on 2008, and when I talked to HP, they said they're coming out in a couple months. But you have a number of options, HP, Dell, and IBM ones. And then for the parallel data warehouse, you have, I just went down there and verified that they are now, people can order it, the version 2, I should say, and they've just delivered a couple of them. HP has, Dell is a little bit behind, but they're taking orders also. They're expecting to deliver them shortly. So we'll cover each of these. The first one is the business data warehouse appliance. So it takes the fast track architecture, and it also installs SQL Server and the operating systems on it. So they tuned and tested it in addition to the hardware with the operating system on there, and all those configuration parameters I talked about, they do that for you. Again, this is 2008, the one I'm talking about now, and I think they said in the first half this year is 2012 coming out. But Dell does have this in the 2012 version. On the bottom, it's called the Data Warehouse Appliance 1000 and 2000. So they are ahead of HP in this. You have a single point of contact. So if there's a problem with the operating system or the software or the hardware, you call one person. It used to be a Dell person, but I don't know if they still do that. But you'd call Dell even if it was a Microsoft problem, and they would call Microsoft and handle it all for you. which can be a pain. If you ever seen, everybody points fingers. Oh, it's a hardware problem. Oh, it's a software problem. It's a SQL Server problem. It's a DBA's problem. Being a DBA was always our problem. It also comes with a quick deployment wizard and a data loading wizard. You plug it in, it asks you a couple of questions through a wizard, and you're off and running. And it also has the same thing for loading data. It could be part of a larger solution, a PDW hub. This could be one piece of that architecture. And you see this got 2 CPUs, 96 gigs, 2 terabytes. Not too shabby.
What is that 2 terabytes made up of? Kind of disk subsystem?
Oh, it's all direct access. I think the Dell Quick Start is direct access. I can't remember if the HP one was. But please go downstairs and contact your Dell representative, who's be happy to tell you. So taking it one step further, maybe I also want to have SharePoint installed on there and PowerPivot installed on you. And having installed many SharePoint installations and along with PowerPivot and all the other BI tools, man, that could be a real pain. They do it all for you. They tune it all. They make it all work together. You just call them up, say, I want one of these. This is for BI, a BI solution. It's made specifically for that. Again, you have the single point of contact. Again, you have the quick deployment wizard. You call them, they deliver it, you plug it in, and you go.
Using this box for your data warehouse, or would you be using it to host your SharePoint instance, your reporting services instance, and the SQL Server instance that's on there is actually supporting those environments?
Yes, to your second part. I'm glad you're here because you're keeping me in line.
There, but if you're going to install it integrated, you would need SharePoint.
Yeah, so let me clarify. This is not considered a data warehouse appliance, so it's not fast track compliant completely. It's got parts of it in there, but it's a solution geared for a SharePoint solution, which needs SQL Server to run on there. So I've seen people use it because generally when you have data warehouse, you're going to have SharePoint on there.
Right, but typically, if you're going to do appliance route, you probably not, at least from what I've read, I could be wrong, you wouldn't want to put your data warehouse directly on your.
Yeah, so, and I'm writing this down because that's a great thing, is you want to have this as a smaller solution. If you need a large database, then this is not the way to go. This is we need a BI solution, we don't have a huge data warehouse, we need SharePoint, let's get this. And a lot of times this progresses into something else where they build out the solution you're talking about. But let's get something going. So great point that you've made me make now is, so I see this a lot in somebody, they want to kickstart, they want to prove out a concept, but they don't want to spend weeks, if not months, putting this machine, putting all these parts together. So they get this appliance, they run a POC on it or a small data warehouse project on there, up and running quickly. And I have plenty of clients, we do POCs in like 3 weeks, and we call Dell and have this machine ready to go as soon as we get on site, and then we build it all out. Or we can ask the client to do all this stuff together, and boy, that could take forever if they do it on their own. Good point. So here's what happens. You plug it in. This is the first screen you're going to see. Give me your domain, your username, and your password. And it goes through the steps, and it's all ready to go. And then when the users log onto that domain, they'll see this. The SharePoint site all ready to go. So SharePoint is a fantastic product, but installing it has a lot of tweaks to it and a lot of security things you got to do. And if you need something quick, this is a great solution to it. And most people don't even know this is out there. And I didn't know about it until maybe it came out, I think 2 years ago. And I was like, wow, this is great. And I started talking to clients, and they said, yeah, we didn't know about this. Let's just do that. So when I call clients now, I say, if you don't have anything built, just go order one of these. Save us all some time and trouble. So the database consolidation appliance, how many people have heard of this? Just a couple. This was announced, I think, at Summit 2 summits ago, and they made a big deal about it. And I haven't heard a lot about it lately, but it serves that SQL Server's database sprawl, where I've been at plenty of clients, and they have all these, I'd sit down and map all these servers that they have and all these data warehouses they have, and there's 20, 30, 40 of them everywhere. And some are these different versions of SQL Server, and somebody's managing them all. And then they have hardware that goes out of warranty, and it's a big, big, big pain and problem. This allows you to consolidate that. It's a virtualized system that it's a Hyper-V environment. It's your own private cloud, and you can, through Wizards, you can import all your SQL Server, no matter what version it is, on virtual machines inside this one virtual box. And you can get rid of all those other there. So you're saving a lot of money because you're getting rid of all this other hardware and you're having one giant Hyper-V cloud for you. It does load balancing for you. If you have a certain machine, SQL servers on there that are used more than others, you can load balance it. It does it automatically. It provides high availability. If a machine goes out, it'll fire up another virtual and copy it. It makes it really easy to create another SQL Server version. If somebody needs one, hey, what version of SQL Server do you need? Well, we still got 2000 database. All right, we'll put it, or 2005. We'll put it out on there in a matter of minutes. Not unlike what Amazon does now with their AWS and all that stuff. Except this is your own personal cloud one.
Would you consider this a high-performance environment or more of a, hey, we've got a lot of underutilized hardware, too many SQL Server instances out there on too many different boxes, and we want to reduce our rack footprint?
Pretty much the second part you have. I haven't seen anybody, if they are having a high-performance database, that's a whole other thing they get. They get one of those other appliances. This is used for a lot of those little databases everywhere, which some of them have hundreds of them in there. And obviously, if you have one that's overwhelming everything else, you could have an issue. And when that happened with somebody, they didn't realize how much something was used. They created it all, and they quickly realized this one database was overwhelming everything, and they quickly pulled it off and pulled it in another solution. So you can see it's 192 cores, all these disk drive. It's a pretty big option. It works great, and they're coming out with another one, I said second half of 2013. Although the one they have now, you can actually use 2012 SQL Server. You can create a virtual with it on it. But some of the parts underneath it are in 2008 Windows and 2008 System Center, and the new version coming out will have 2012 for those.
So is this
This is not data warehouse specific.
So, and I asked the same question, and they said it's still tuned for, the whole point is to bring databases over, but I said, are they data warehouses? And they were kind of like, yeah, you can use OLTP, but it'd be very small. You don't want things that can be updated because it can overwhelm everything else in there. So the gist I got out of it is, I would say, yeah, it's for data warehouses that you have all over the place. Although you can have an older system that's nobody using much, and it's no OLTP, but it's rarely used, and you need to archive things. So you can have a mixture in there, I would say, but you wouldn't want to use this to really drive something that needs a lot of performance. Yeah, yeah. Unless you talk to the HP guys, they'll say, oh, it works for everything. Yes, sir.
And automatically load balance only the data.
Say it again. Hold on. I would get you a mic, but they don't have an extra one here. Thank you, my man.
Have you automatically load balance only the data house.
there's no like automatic load balancing on that, where it does swaps of the load onto different virtual machines? That's not what this does.
Right, it won't swap the machines. You can adjust the CPU usage and the data, the space usage on there. And you can assign more cores to certain machines, and you can assign more space to certain machines.
Because SQL don't have the hack.
Yeah.
The same auto hack. No load balance.
Yeah, so, and you're probably getting into more details than I know about as far as how all that load balancing works. But I can follow up on that and let you know. So, good question.
Is this something that you would buy directly, or is this
Well, this is, I mean, you call HP and say you want this specific thing. Right, yeah.
Okay, so I was curious, because I thought I heard you say that this is more of a cloud.
Well, yeah, but it's your own internal private cloud is the way they'll say it. You call it, they give it to you, and they're like, here's your cloud. And it's all done internally. Nothing is outside your environment. So I should need to clarify that. Yeah. Good. So here's the kind of idea. On the left side is the custom built solution. It could take months to do it because you got to do all these steps in there. If you choose something like database consolidation appliance, you cut those months down into weeks there, especially when you need to fire up another one. It's just a matter of clicking a button. And I have seen this. I know one of the Microsoft guys, and he tells me, he installs these things, and he tells me how great they are. And he said this is very accurate, and how quickly you get it up and running and providing, compared to doing everything on your own. Oh, and they also actually have a reference configuration for this. So if you wanted to not call HP and instead build on your own, there's a paper that will tell you how to do it your own. Although honestly, I'm not seeing Microsoft or HP push this a lot, and I don't know if it's because you have these cloud options or not, and that's cutting into it. So, I would say, look at this and then look at external cloud options. But a lot of people, outside cloud is for security, they won't do it at all. So for those people, this is a great solution. For other ones, you may look at, your Amazon. So the parallel data warehouse. This is a multiprocessor system. It's I started updating this for version 2. On the right-hand side, you'll see they now have, it used to be 2 racks minimum. Now they have a quarter rack. And it goes from, again, 15 terabytes because they lowered the minimum in there because of the quarter rack to 6 petabytes. And up to, a lot of cores, almost 900 cores on there. So how this differentiates between regular SQL Server is SQL Server, the SMP version, it's only scaling up. You can't scale out with it, right? With MPP, you can scale out by distributing the query loads over multiple servers. And you can keep adding servers and keep improving your performance. So it's a scale out and not a scale up. It works great for complex workloads, very high concerns, relatively high concurrency. It has high availability built into it. If something fails, it's all virtual now, and they'll kick off another virtual machine. It's a bit limited on its SQL Server functionality. It doesn't have 100% of all the SQL in there. And I've been on 2 projects, and I ran into not a lot. And there's usually workarounds, but I have a nice list of some certain SQL you can't do on there. They didn't have like the truncate command. You know what? I'll tell you, if you email me, I will send you that list of all the issues I found in there. But there was SQL like you couldn't do the truncate. You had to do this. They call it CTAS, was create and select to get stuff in there because you couldn't truncate a table. There was problems with some of the order buys. There was all these little tiny things in there. If you understand the whole history, this was something they purchased from Data Allegra, and it was on Unix, and it was on a different. It wasn't using SQL Server at all, and then they reconfigured it to use on Windows and to use SQL Server, and that took a lot of time, and they didn't have time to make it completely compliant with all the SQL Server syntax, the T-SQL.
Is that because they didn't do it?
What?
Go ahead, sorry.
Did they address any of them in version 2?
Yes, they did address it. I was just talking to him, and he said they fixed a lot of them, and a lot of them are in the next update, the CU update for that. But that's what they're concentrating on now. In SQL 2012, they've added a lot of features, X velocity, column store, and that. I'll go over that in a minute. They didn't even have, you had to use a thing called Nexus. You couldn't use SMS. That is fixed in version 2. Now you can use this as a mess. And any other front-end tool you want can be used now. Before you had to use this other product. So it was kind of, it had issues. There were workarounds to get around everything, but it just made things more time-consuming. So they have, this is kind of layout, and this graphic is still version 1, but you can build out the version 2 to be very similar, where you have control nodes. That's a single connection point for your SQL queries. They'll go to the control nodes and they're going to farm it all out. You'll have some failover zones in here. You'll have some customer spaces where they can install their own backup nodes and landing zones. Landing zone is where you move the data, kind of a staging area. And then you have 8 storage nodes, each with disk, each with partitioning them out. They're using direct access storage, and then each of those compute nodes has a direct storage node, and it's built so the compute node has 8 cores, and then it has the storage node that has 8 kind of channels into, or pathways into those cores. So it's it's solving that problem of feeding the CPU and maxing it out. The way they design this is those CPUs will go to 100% because they're getting the data quick enough. That's how they solve this problem with the way they architected it. So you'll see here, if somebody will go and submit a query to the control node, that will get parsed out to all those compute nodes because the data is distributed over all those different storage nodes like that. And you use a hash index to define how you spread it all out. And there's a whole things you got to watch out for that because you don't want to have too many on one and not enough on another. But if you use something that's unique as the hash index, it'll spread it out evenly so the queries can go off and all do their own thing on each of the individual compute nodes, send the data all back to the control node and then send it back to the user. So you're not hitting one table with 1 billion rows, you're hitting multiple tables with less data in there, and I'll show that in a minute.
So you have to, as the database architect, specify which column or combination of
Yeah, you pick that.
hash.
Yeah, you pick one. And it's a little art in that. You don't want to pick a state, like that. But you quickly find out if you pick something wrong because
You're not actually changing the schema of your table. That's
no.
just used
The cool thing is everything else you don't even realize you're hitting an MPP. It's pretty amazing. You just submit the query and it goes off, and you don't realize all the stuff going on behind the scenes like that. You just got to design your tables with some things in mind. And the cool thing too is while that's going on, you could be loading the data at the same time without causing performance problems. Because they had to use this thing. They use this. I think you can see it on here. Dual InfiniBand. It's an internal network that is multi-gigabyte cards that they use on there. So the performance is extremely quick because of the extra bandwidth that they have when they're all talking to each other. So kind of along what I was saying. Oh, go ahead.
From what you mentioned, it sounds like data skews potential problem. They have tools that allow you to view the data distribution so you can detect that something's.
Yeah. You can see. They'll have graphs where you can see how it's all distributed, which kind of gets along in here. Is you want to distribute large tables. You don't have to distribute smaller tables. If I have like dimension and fact tables and I have a dimension table that's only a few thousand rows, I can say I want to replicate that. So every compute node out there will have a copy of that. And so you don't have to worry about this distribution thing and index keys. But on the large tables, your fact tables, you want to distribute them all over, right? And so when you submit the query, what the query will do is, okay, we can say this compute node has everybody who has last name of A. And I'm going to join that with all the dimension tables that are replicated there and send it all back to you. And then every compute node is doing that. And they send it all back and combine it all, like with the unit all, and send it back to the user. And eventually it's called an ultra shared nothing because you can just plop in another. Nothing is relying on another one. You can pull one out or put one in there without affecting all the other compute nodes in there. And There are gotchas if you do certain joins and you don't do things that they recommend. You can call what happens called shuffling, where it'll have to move data. Oh, you want this table and this table's over here, so I'm gonna have to go move it over there. And you quickly see when there's a problem because your query will take forever. And you can look at their management node and you'll see where it says the query plan, and you'll see where it's shuffling and things like that. It just takes it took me a few weeks to kind of understand it all and figure out the gotchas, but after that, it was amazingly fast. So they gave this demo, and I don't have a PDW here, so it's kind of hard to give demos sometimes, but they ran this at the one before last, where it was 100 terabytes, 600 billion rows, 220 billion rows, and the query ran in less than 20 seconds. And that was not an easy query. It had a group by and an order by in there.
Do you know whether that demo was utilizing column store? Or
No. So everything I've talked about hasn't talked about version 2, and we'll get that in a minute. I ran the same, oh, go ahead.
You talked about group by and order by. Does that happen on the control node? Can it happen?
So you don't care how, you're going to write that without caring what it's doing, but behind the scenes, the compute node is determining the best query plans to use, and it distributes them out, and through magic or whatever, it has each compute node do its own thing, and then it brings it back.
No, but I think to the question, if the data is distributed across multiple compute nodes, and depending upon the aggregation that you're performing, it can't, at least it seems like, if thinking about this correctly, you can't do the aggregations on the compute nodes.
Right, yeah. And so there are some, and that's what you'll see where you can design it to minimize that. It's a long way to explain that, but the short answer is, if you design it right, that it's not going to be a matter. You can design the indexes and things a way that doesn't affect it.
But how do you manage with a dimensional data diagram schema, and your facts are partitioned for storage specifically by year, a full date key type of thing? I've been told we have to drop all our non-clustered indexes. So, okay, but the clustered indexes with the fact tables are partitioned by, so there's going to be different partitions, or we can lose the partitions. Microsoft just hasn't told us yet. Our concept starts in Minnesota for 2 weeks.
I asked that question of somebody earlier who was talking about the internal architecture on it. So basically, it's two levels of partitioning. There's the distribution that the control node does. And
Yeah.
You still have your table level partitioning. So you actually would have a different hash
Right.
that would separate the data out almost at a subset below.
The calendar.
Yeah, that's pretty much it.
Unfortunately, one of our DEMs is almost 2 terabytes of DEMs. I know. But, so how's it going to shuffle that everywhere so that it can be next to the other 20 DEMs that they might inquire on at the same time? Promote
Yeah.
that. Second.
You would probably replicate that dimension across every one of the compute nodes so that it wouldn't have to do the shuffling. It would keep a copy of that dimension on every one of the compute nodes, and maybe use a clustered index on the dimension. Most people are using one fax, but if you've got a very large dimension, you have a clustered index on it, let it replicate the compression, and you're keeping it close to the fact data.
That's it. Yeah. We're running out of time, so otherwise I'd be happy to explain it more, and we could take it offline. But in the end, when I would run some of these queries against 1 billion rows, and I hit return and it comes back, I would think, oh, I must have a syntax problem. What's going on here? And I realize, oh my God, all the data is there. It's really incredible. So here's how it works, and I like to show this. If you have a table that's 600 billion rows, it takes that table and distributes it. Say we're using 40 SQL servers, so divide that by 40 and you get 15 billion. So now we're spread out, and the biggest one is 15 billion. But then on each server, it distributes it to 8 tables because it has 8 cores, so it has 8 partitions. So you divide that by 8, so you get about 2 billion. Then if you decide to partition each of those tables out by, say, 2 years, so you have by week, so that's 104 weeks divided by 104. So now all those queries that are being executed are going against 18 million rows, and not one query going against 600 billion. So when you look at it that way, I was like, oh, that makes a lot of sense. It's just distributing the data out and sending the queries along to do each of them do the work on their own control nodes. When I read about Hadoop, it's behind the scenes. That's what this is kind of doing, is the way Hadoop works.
So the file group and all of the stuff you classically have to worry about when you're partitioning a table in an SMP environment, the infrastructure of the parallel data warehouse takes care of that for you. It figures out, based upon your partitioning scheme, how to allocate, because you're not dealing with lungs now, you're not in a sand environment anymore. So it figures out how to spread it across the direct storage, the direct access
Yes.
storage within that.
All based on your hash index. That's why you got to be careful about that. But you do specify the partitions in the last one. That's part of your create table will be that part.
Just on that alone, it seems like it's a huge time savings.
Yeah, it's incredible.
All that storage.
It's
crap,
yeah,
figure
that's
out where
yeah.
you're gonna allocate it.
Yeah, once you start using this, you realize, oh my God, this is a godsend. And you don't, like I said, you don't have to worry about how that's. All you see is one logical table. You don't know behind the scenes there's actually 320. So this could be part of a hub and spoke architecture where you have the central EDW hub, and then maybe that farms out and sends data to data marts. If you were in the previous Marco's session where he talked about data warehouse and data marts, that could be your data warehouse, and you can send out data marts all over the place. So again, it's a scale out instead of a scale up. It uses MPP, it uses that infinite band. It fills them. I went over all this, and you can use SSIS to load it all, or you can use these DW loader, kind of a bulk thing. But it fills a missing piece for Microsoft, because Microsoft was losing customers. People would scale out, and they would say, well, we need something bigger, and Microsoft didn't have a solution, so they go to Teradata or Netezza. But now they can go stay with Microsoft. So, and the other thing I want to talk about is the version 2 stuff. So version 2 came out with X velocity and column store indexes, which supposedly have a 10 to 50% faster on there.
I can just share some personal experience working with column stores in a SMP.
Yeah, so you know,
I've got a fact table that's approximately 10 billion rows, partitioned by day, a clustered index that is 4 parts, pre-column store index working with completely ad hoc queries. Worst case query times were anywhere around 30 minutes working across 2 years worth of data. Now, sub-second.
yeah, it's incredible, isn't it?
Sub-second.
Yeah.
It's 10 billion rows.
Yeah, and I've heard that many times. So it has that, and also it goes one step further, and they're updatable column store indexes here, which we don't have yet in Rega 2000. These are updatable, so that's a nice thing. Like I said, again, it uses SSMS. Version 1 didn't use that. It uses Windows 2012 storage spaces, Windows Server 2012, SQL Server 2012, obviously. It uses Polybase is the other thing. It has a Hadoop connector, so you can call Hadoop unstructured data and call SQL Server stuff in there and mix them together. And it has upgraded hardware, obviously, and that's where the price point is much lower, because they give you better hardware, it's cheaper, and they have quarter racks you can get now. And the really cool thing, and you can go downstairs and see this demo because I just saw it, is they took PowerView and they created a tabular model using direct query, which is a pass-through. So he was showing me, he was running PowerView without having to create a cube that was hitting the parallel data warehouse. And it was very, very fast. And the biggest problem I had with parallel data warehouse when I was at NASDAQ was we were building a cube from it. And when you're talking about billions of rows, we had to partition the queue by day. And even that, we'd have to update it during the day with multiple file dumps. And that could take 2 to 3 hours to do with just one day. And, oh man, if I change something in the queue, I had to reprocess the whole thing, we'll forget it.
Are there any implementations you're aware of where people are actually putting the analysis services instance on a PDW box?
No, it's all separate. You can't put that on the PDW. I don't know if anything changed about in version 2, but they said no, it's got to be separate. And you could put SSIS on it, but nothing else, no report service, anything like that. So in the end, they had, when he was showing me the demo, it was amazing.
Do you have any idea what the price point was for quarter rack?
No, go down there. It varied. I don't even want to say because it was quite expensive with version 1, but now that they have a quarter rack, I don't even know, what that is. So, just to wrap up, they have some, like I mentioned, they have a fast track for SQL Server on these slides. It will point to it. They have a private cloud reference architecture if you want to use it, and they actually came out with OLTP reference architectures. No appliance, well, one appliance on there that HP has, but they're trying to do the same thing with the reference architectures for OLTP now. So I expect that will, in the near future, you may see more appliances for that to solve that issue like that. So there's my email and contact information. Please feel free to call me if you have any questions, or send me an email. I'll be happy to answer any questions you have.
You're not going to buy one of these just on a whim. Do you know of anybody that's got a lab that they're actually have quarter racks or something similar available where you can do a POC without actually doing the...
Yes, so you have some of the consultant companies that are partners with them, have them. So there's 2 or 3 consultant companies I know that have purchased quarter racks, and they do POCs with them if you call them. You can also go to Microsoft Technology Centers, and they have them, and so clients will go there and do their POCs at the Technology Center. And then they have like a kind of a virtual one that if you go downstairs, he'll show you. Ask any of the Microsoft guys. John down there, and he came from Data Allegro, and he's giving demos of it on there. So thanks everyone. I know it was a canceled session, but I appreciate your time.